2015 question 11. In the species below, the underlying atom is the central atom, and all non-central atoms have octet electronic arrangement. In which of them does the central atom not have the octet electronic arrangement? So these type of questions, immediately you can write down their electronic arrangements, and you'll see on the left and right whether they balance out each other or not. Say, for example, we have SF2 for option A. Here, sulfur, I'm just going to write down its outermost shell electron number. So sulfur, it is in group 6. Its outermost shell electron number is 6. So 6 electrons in its outermost shell. And how about for fluorine? Fluorine, it has 7. It's in group 7. It has 7 outermost shell electrons. Fluorine, you can see there are 2 fluorine atoms. So I'm going to write down another fluorine atom here. So simply, what you have to do is you need to balance out the numbers on the left and right. How can you balance out the numbers? You need to first see how can you make these electrons, these atoms, stable. So for 6 electrons, in order to make it stable, I need to have 8 outermost shell electrons. That means I need to have 2 more electrons. For fluorine here on the top, I need 1 more electron in order for it to become 8. The other fluorine atom, I'll also need 1 more electron to make it become 8. And then you're going to see how are these electrons going to come about. Where are these 2 electrons coming from? They're being shared from, obviously for sulfur, they're being shared from fluorine atom on the right here, sorry. So one of the electrons come from here, the second electron comes from here, and this is what I mean on the left and right, they should be balanced. 2 electrons on the left, it's being shared where the other 2 electrons are being shared from, which is fluorine here. 2 on the left, 2 on the right, that means this is following the octet rule. If there is an unbalance, if there is not a proper balance of electrons, that's when it's having a non-octet electronic arrangement. So CF2, do the same thing. So this, you can notice that this method helps you save a lot of time. Carbon, 4 outermost shell electrons. Now how can I make it stable? By adding 4 more electrons. Fluorine here, you know there are 7, because there are 2 fluorine atoms. I'm going to write 7 outermost shell electrons. How can I make it stable? By adding 1 more electron. 1 more electron. Now you will see that on the left hand side, I need 4 electrons in order to share them with carbon to make it stable, but here I can only give 2 electrons. So you can see now there is an imbalance. There are 2 extra electrons remaining to be shared. So if there are extra electrons, then it's following the non-octet structure. So B is the answer. You can try and do the rest by yourself. CS2, I'll still do it for you. CS2, carbon here, it's having 4 outermost shell electrons. So I need 4 more electrons here. Sulfur, you can do the same thing. Sulfur, this time it's in group 6. So 6 and 6, it needs 2 electrons each. So you can see that now they perfectly balance out. 4 on the left here, 2 plus 2, 4 more on the right here. So C is wrong. And the last one, NCl3. Okay, for N, nitrogen group 5, I need 3 electrons. Cl, there are 3 of them. So I'll write it up here, don't have much space. Cl, Cl, and Cl, group 7, 7, 7. I need 1 electrons each. 1 electron, 1 electron, 1 more electron, and these also perfectly balance out with one another. Okay, so at the end of the day, make sure the electron numbers are shared. If they're equally shared, that means they are following octet electronic arrangement. If they're not, then it's non-octet. So answer for this is B.